All right, next comes insertion sort. Sorts a list by moving each element to its proper place in the sorted portion of the list. All right, so this is going to be a little confusing at first, but the idea is that we're going to build a list that's sorted. So if you start at the first element, if an element is an element of 1 sorted? Yes. So we're just going to add the next element and put it where it needs to be, is the idea. All right. So like I said, we're building a sorted list. 1 element of 1 is always sorted. You add the 18, make sure they're sorted. 25, well, naturally it's sorted. And 30, okay, so far it's sorted. So then you have a 23. Where does the 23 need to go in this? Between the 18 and the 25. So what does it need to do in an array?
Go to the second element.
Right. So you, well, do you swap it?
No.
No. What do you have to do instead?
Pointer.
In an array, what do you need to do?
We'll put it at that position and then shift everything over to the right.
You probably want to shift first and then put it over, so you don't overwrite value. Yes. So they copy it to a temporary storage. Notice here, 23 is over to a temporary. Then they copy everything down. So 30 is going to go over 23, and the 25 is going to go over the 30. Which way should you do this? Should you do it to the left to the right, or from the right to the left?
Left to right.
Wait, what?
Left to right.
So if you did left to right, the 25 would go over the 30, and then you copy the 25 over the 23. Is that what you meant to do? No. You want to copy from the right to the left. Otherwise, you're going to overwrite everything. Insertion sort's a little tricky, especially for arrays. So notice that it copied everything over. That you have two 25s there, but what are we going to do? We're going to copy from our temporary to that location, and then we're done. Okay. Wow. Did that seem complicated?
It's counterintuitive because you're like thinking you got to shift everything down, but actually you shifted it. You know what I mean? It's counterintuitive.
All right, let's do a full example on the board. This time I'm going to use my red marker. Okay. All right, let's get some more numbers.
12.
12?
8. 6. 4. 2.
99. 98. 87.
Oh, you're just being mean. All right, stop it. Oh, yes, nice and clear. Okay, so we're going to do insertion sort. There's the array of just 12. Is that sorted? 12 by itself.
Yeah.
Oh, yeah.
Yes, array of what element is sorted? That is a great assumption to make.
Yes.
We're good. All right, we're going to go ahead and look at the. So we're here and we're here. So that's happy face. We're sorted. Now we're going to move the arrow over here. Is that sorted?
No.
No. What do we need to do? We need to switch the two. All right, we're just going to swap it this time, just to make it easy. But in your code, you should not be swapping. And I'll show you why in the next iteration. So we're going to do comparisons. Whoops. And then we'll do moves. I don't know why I decided move should start with a W, but it's moves. All right, so the first iteration, we did one comparison and we did, we'll say, one move. What's that?
So, is it? Seems tedious.
Yes, it's going to be tedious on the board. And now I'm going to ask the question, why are we doing this? All right, so next we're going to move the pointer over, or we're going to evaluate the array from the beginning to here. Is 6 the lowest? I mean, is 6 in the right location? No. How many comparisons do we have to do in order to achieve that? 2. All right. So where does the 6 need to be? But everything else has to be shifted over. All right, let me show you the order. First, you create your temp variable, set it equal to 6. Then you first move the 12 over here, okay? So we're going to take that 12, we're moving it over here. Then we're going to move the 8 over the 12. Right. And then, now that we've shifted everything over, what do we do?
Put the 6 in the next thing.
Put the 6 where the 8 is. All right, we did 2 comparisons. How many moves do we do, or assignments? 3. Okay, yeah, 10, we'll say 30. All right, now, you're so mean.
It gets better.
Oh, I know, I can tell. What? All right, is the 4 in the right location? How many comparisons do we have to do to find that out? All of them. So 3 comparisons. All right, we move the 4 over to temp. We're going to move the 12 over. We're going to move the 8 over. And then we're going to move the 6 over. And then we're going to put the 4 where the original 6 was. How many moves do we do? 4. All right. It's sorted, right? Mm-hmm. All right. Let's go evaluate the next one. Oh, it's a 2.
Just erase it, and we'll just keep going with the rest of it.
Nope.
You just say it's a 14 instead.
Nope. We're this is actually a good example. You got, because you're going to have to code this, obviously, so sit tight. Is the 2 in the right location?
No.
No. All right. So we take, where's the 2 need to go? At the beginning. How many comparisons do we have to do? A lot. 4. All right. So we move the 2 over. All right. We're going to move. Whoops. We're erasing the 2, putting a 12. Erasing the 12, putting an 8, erasing the 8, putting a 6, erasing the 6, putting a 4, and then this 2 is going to overwrite that 4. How many moves did we do? 5. All right.
That's the wrong answer.
No, but it's not looking good for this.
Did I say the wrong thing?
No. It's as in. Do you think it's going to be better or worse than selection sort?
Worse.
Worse. All right. There is no 2 to the end here.
Oh, no. It's 2 to the end.
No, that's going to come later.
2 to the end, to the end.
To the end? Just give up all hope now.
It's okay.
If you're trying to do 2 things.
It's over. All right. We again, increment the size, look at 99. Is it in the right location?
Yes.
Huh. How many comparisons do we have to do?
None.
Well, we had to compare it against everything else to find that out, right? So we're down to 5, so that's 5th. How many moves do we have to do?
None.
Yes.
So that's where it's kind of nice. Oh, yeah.
Kind of, yes.
If it's already.
If it's in the right location. All right, let's go ahead and evaluate the 98. Is it in the right location?
No.
No. How many comparisons do we have to do for that? All of them, 6. So let's take the 98, move it over to our temporary variable, move the 99 over. Make sure you're doing it this way. And then, that's the funniest 99 I've ever drawn. 99. All right. Then take that 99 and replace the 98 with it. All right. How many moves do we have to do? 2. We'll say 2, yes. All right, 7th one. Let's move an arrow over. 86 in the right location? No. How many comparisons do we have to do to find that out? Yeah, 7. Actually, we only have to do 6 this time, because once we got to 98, we were done.
Oh, not bad. That's cool.
All right, so we're going to move the 87 over to temp. We're going to move the 99 over, move the 98 over, and then we're going to move our 87 to overwrite 98. All right. And how many moves was that?
3.
3. All right. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 elements. There were about n-1 loops. Because if we extended this out, if it was 100, hopefully you see we'd have to loop through this 99 times. The comparisons, what were the comparisons about?
The same number of size.
Yeah, just kind of the opposite. So it's, on average, a comparison was probably half of n, right? So what's your big O of comparisons? So it's n-1, because you had to do it n-1 times, and each time you had to do it roughly half of n comparisons, we'll just say. Which is big O of what?
N squared.
N squared. All right, let's do moves. Again, you got to do it n-1 times. And each time, how many moves were there? On average, probably half of n. I don't know why I wrote half there, but let's do it this way. It works. It still works. I think it's prettier this way. Which again is O of n squared. All right. So for this, is insertion sort any better than bubble sort? No. So it looks like
It's worse, right?
it's the same as bubble sort.
It's the same.
It's going to be about the same as bubble sort.
Which one do you prefer?
That is a question I'm asking you.
Thank you.
All right, let's go compare them all. We did this analysis up on the board, roughly, but when it comes down to it, number of comparisons in bubble sort, n squared, number of swaps, n squared, selection sort, n squared comparisons, swaps, O of n, insertion sort, n squared, number of swaps, n squared. So if you look at this, which sorting routine is the best?
Selection.
Selection sort looks to be the best. For an array. Ooh.
Thanks.
Well, what do you think's happening next?
Linked list.
Linked list. All right, let's stop the video and talk about that real